Okay, so this is Microlecture 9 on resonance hybrids. Resonance hybrids can be drawn in some cases, not very many, when the molecule is pretty small and straightforward. We use dotted lines to indicate a sort of half-formed, half-broken bond. And you can use partial charges like this or simply delta minus. Okay, so here's an example, or three examples actually. We have the case of a benzene ring. We have the case of a nitro group. And we have the case of an allylic carbocation. So for the case of benzene, we know that we can draw a resonance structure of benzene where the pi bonds are just kind of moved around within the structure. If we wanted to represent that just as one drawing, and we often do this, we could draw a hybrid structure for this molecule. And so with a dotted line, you can indicate that the bonds are half single and half double bonds simultaneously. And that's the same thing, by the way, as when we draw our benzene ring with just a circle in the middle, just because it's easier and faster, and there's a lot of benzene rings in this course. So for the nitro group, we know that there is a resonance form, and if we don't want to write out both resonance forms, we don't have to. We can write out, or draw rather, a resonance hybrid. And so the hybrid can be drawn this way by having sort of 1.5 bonds. The single bond is the one bond, and the dotted line is the half bond. Both of them going to the oxygen, and that leaves a sort of a negative 1/2 charge on either of these, or both rather, simultaneously. If we don't want to go so far as to label the exact charge, you could also indicate that these oxygens are both delta minus, so just show a partial charge. The last example is an allylic carbocation, so the resonance form looks like this. So if I wanted to draw a resonance hybrid of this guy, so I didn't have to draw both resonance forms, then I would put half a bond here and half of a bond here. So with my dotted line, I would show 1.5 bonds on both of these carbon-carbon bonds, and then we can indicate that there is a sort of a partial plus charge here and a partial plus charge there. Again, really that would be a plus 1/2 charge on both carbons, but we can use the delta. We don't have to label the actual magnitude of the charge.